So in today's video, we're going to go ahead and briefly cover the integral of inverse trigonometric functions. And we're not really going to go over many examples over here because at this point it's kind of just basically using constants to try to manipulate the integral and everything. But what I really want to do is kind of see how these integrals relate to each other. So we know the derivative with respect to x of sine inverse of x, which is also referred to as arcsin of x, and we're going to use either notation, whichever one you prefer. That's going to be equal to 1 over the square root of 1 minus x squared. And that kind of just tells us that the indefinite integral, the antiderivative of 1 over the square root of 1 minus x squared dx is just going to be equal to arcsine of x plus c, or inverse sine of x plus c. And then with respect to cosine inverse, or arccos of x, if you will, the derivative of that's just going to be equal to negative 1 over the square root of 1 minus x squared, and hence the integral of that is just going to be equal to arccos of x plus c, or cosine inverse of x plus c. And so immediately we can tell, well, the derivative of cosine inverse of x, the derivative with respect to x of cosine inverse of x is just going to be equal to the negative derivative with respect to x of sine inverse of x, right? And we can actually see, that's just kind of given from the fact that there's really the only difference between these two derivatives is that there's a negative sign for cosine inverse's derivative, and hence their integrals are going to be negatives as well. So we can say that the integral of negative, or if you will, the integral of negative 1 over the square root of 1 minus x squared dx, which could just be equal to cosine inverse of x plus c. We could just remove that negative sign. That will be 1 over the square root of 1 minus x squared dx, and then that's just going to be equal to negative sine inverse of x plus c, right? And the constant doesn't really matter much. And so essentially over here, the point I'm trying to make is that when we're going to be considering these inverse trig functions in the future, we're not really going to focus on both sine inverse and cosine inverse. We're primarily going to focus on the integral of sine inverse of x. And essentially the whole point of this video really is to kind of introduce these integrals and then see how we can use substitution to evaluate much more complicated integrals using these inverse trig functions. And there are two, and I'm just going to tell you them right now, two inverse trig functions that we're really going to focus in on that are kind of the most relevant, and that's the derivative of sine inverse of x, so 1 over the square root of 1 minus x squared, and also the derivative of tangent inverse of x, which is over here 1 over 1 plus x squared. And essentially the reason for that is because any constant multiple, and you even notice over here that these are just constant multiples, and particularly these are just negatives of each other. Like what we saw with tangent inverse and cotangent inverse, the derivatives are just the negatives of each other, and then the same will apply to their integrals, and same thing with sine and cosine, or with cosecant and secant. And so ultimately, we're only going to focus in on two, and that's sine inverse of x and not cosine, my apologies. Sine inverse of x and tangent inverse of x. When you take these derivatives, they're going to be very, very crucial for actually evaluating much more complicated integrals. So this right over here, 1 over the square root of 1 minus x squared, and this one over here, 1 plus 1 over x squared, or 1 over 1 plus x squared. These two integrals right over here, these two are derivatives really, are going to be very crucial for evaluating much more complicated integrals in the future. And so that's why we're not really going to cover these inverse trig derivatives and integrals too much, because really we're only going to focus in on this one over here and this one over here. But we can quickly go over these as well. The derivative of cosecant inverse of x is just negative 1 over the absolute value of x times the square root of x squared minus 1. This kind of derivative over here, it's not very common, especially at like an IB HL math level or an AP calculus level. So you won't really have to focus too much on these ones, especially involving like the absolute value, like with secant inverse and cosecant inverse, because you won't necessarily be dealing with this too much, but it is always good to know. So in case you get a very intense integral involving absolute values and square roots, then maybe you can try to find a way to manipulate it into the form of the derivative of cosecant inverse or secant inverse. And that's essentially the whole point of this entire video, is that you can manipulate more complicated integrals to get it in the forms of the derivatives of, these inverse trig functions, if that makes sense. And so, when we integrate this, we'll just get arc cosecant. When we integrate this over here, we'll just get arcsecant of x plus c. And then finally, cotangent inverse of x is just the negative, essentially the derivative of that is just the negative of the derivative of tangent inverse of x. And so that's really why we're not really going to focus too much on it as well, because when you integrate, it's just the negative integral of the derivative of tangent inverse of x, and hence, that same will apply to the derivatives as well, and the antiderivatives. So ultimately, my point here is to just say that these kind of inverse trig functions, their derivatives and their integrals are very closely related together. They're oftentimes just going to be related by one, like a multiplication of a -1, right? And so that's why when it comes to these different trig functions, or these inverse trig functions, they're mostly useful in integration when we want to try to manipulate a very complicated rational integrand. We want to manipulate it in a way so we can get it in the form of this derivative over here and this derivative over here, especially these two, especially the derivative of arcsine and arctan of x, because everything else is kind of a little bit more, well, they're either just negatives of each other, or they're a little bit more complicated and not going to be very prevalent in at least this level of course in Calculus 1 and Calculus 2, such as these two, integrands over here. You may not really see them very often. Again, it's good to have your repertoire built in terms of being able to recognize and how to manipulate different things to get them in this form. But in general, we're primarily going to focus on the derivatives of sine inverse and tangent inverse of x and integrating them and trying to get the integrand in that form of 1 over the square root of 1 minus x squared, or 1 over 1 plus x squared. And so that's essentially that for now. In the next video, we're going to talk about this may not make sense, as maybe a little bit arbitrary right now, but in the next video, we are going to put it all together and see what I mean by manipulating an integrand to get it in the form of one of these two derivatives over here, or one of these two antiderivatives, I suppose you could say.